We're live, but I'm getting a little spinning. Oh, not getting a spinning circle anymore. Weird that I was getting the spinning circle on Twitch. Usually it just shows that it's offline. But hey, it's stream number 32. My phone made a noise. Anyway, weird phone noises aside, I left this in a non-building state this morning because I had to jump to a meeting at work. So I think first order of business is to fix this. Test for using loop variable is failing. So let's go look for that. This is for using loop. There it is. All right. It's failing because on line 137, it's expecting 0 for foo's value. Oh, well, we're not returning anything anymore, so there's not going to be a value, right? So that's irrelevant. Let's see if that was the only bug. Yep, that was it. Just one thing. It's fixed in like 5 minutes. Okay, so there was a gist to look at from Spoof, and also Geo52Ray sent me a gist. And I think it was, I was working on this where I had this cleanup, like something I wanted it to run on all return paths, and then I had to do it 3 times. I thought of a way to do it where I just nest, like I have 2 functions and one calls the other, and the outer one can do this cleanup on the way out. I think they just had different ideas on how to do this with a generic type. Hey there, Nightshade dude. So I want to go take a look at that. Could I like close? There we go. See, this is from Spoof, their idea of having a guard object, and then you put this, which is our mutable reference, and a dropper function, and I guess this is how we, yeah, that's how we access this, I guess. Is there a use? How come I don't see a use? I see the struct and I see the drop, but I don't see a use. I guess he's saying like you get it by accessing the value. Yeah, sure. So yeah, the dropper is just calling the dropper function with self value. Yeah, so that's one way to do it. And for some reason, it's like moving that window into that workspace. Oh, you know, it's control click is doing that. Okay, so here's this geophrase, or this is yeah, this is Geo52Ray's version of it. And I think it's pretty much the same, right? I think this is just a wrapper for doing the thing, right? Yeah, so there's a guard again with the value and a dropper. And I think this is the one where we can just dereference it to get to that mutable reference, right? Yeah, so it implements deref. Both deref and deref mute. Yeah. So this would make a nice general purpose guard. So I think I'm just going to do a simpler approach where we just have one function calling another, and then like do what I want on the way out of the outer function. Hey there, bathroom homie. To-do driven development goaded. Yeah, we'll get to that. I'm in the middle of doing the last thing that was to do, but yeah, the way I'm progressing through the implementation of my project is I'm searching for the to-do macro, and I'm like, oh yeah, I haven't done binary operations yet, and maps and sets and unary operations and vectors. And when we get through those, then we're searching for all the capital to-dos and comments, and there are a bunch of those, although some of them are for the C++ version, so we're not going to worry about those. But yeah, like this, there's like consider this, refactor that. I don't think it's possible to reach here. Consider differentiating, yeah, all this stuff. So these are more like refactorings, I think, whereas these to-dos are missing implementation, which we're running short on, which means we're almost done. And then once we get done and it's all refactored, next order of business, I think, is to make a shell for the program and verify it actually parses correctly. And then I want to move on and actually allow like us to write scripts in Lua. And why Lua? Because I like Lua. But with scripts in place, then I want to try to do user interface on top of all that. What's this for? I'm glad you asked. So you're going to see these words if you watch my stream for a while. Lexer, parser, ingestion. We're making DataDisintegrator. So it's kind of like my version, just for fun, of something like Wireshark, where you drop in some data and it shows it like a hex editor, but you can also click on the bytes and it figures out what they mean based off of a format that you plug into it. So just like Wireshark has protocol or data dissectors, I think they call them, my tool will use the domain-specific language to allow you to write a description of the data format wherever you want, whatever kind of format you want, as long as you can describe it in this language. Then the tool will use it to basically, this is just a fancy way of saying parse, assign the meaning to every piece of the whatever file you drop in. So, for example, whether you pronounce it GIF or GIF, this is the description of that format. So a file starts with the header and ends with the trailer, has the data blocks, and you loop consuming data blocks until, if you're looking ahead 8 bits, you see a 3B, and that's a signal that it's a trailer, because trailer is a label which has to be 3B. And before all the blocks, there's a logical screen with a descriptor and a color table, and the descriptor has a width and height, right? And when we look at a file, you see how we see GIF 89A? Well, that's because the file starts at the header, and the header says there's a string called signature that's 24 bits long, and then another string called version that's 24 bits long, and that's this GIF 89A. Principles of programming languages flashbacks? Yeah, because if we make our own domain-specific language, we want either an interpreter or a compiler for that, right? So back to your programming class. Like for me, we used the Dragon book, compilers, principles, techniques, and tools, the Dragon book. You generally have 2 stages of a compiler. You have a lexer and a parser, right? The lexer turns your input text basically into a string of tokens that the computer can more easily consume. So there's both a type and associated data for every element here. So that's a identifier, and then some punctuation, and then another identifier, and then down here is a reserved word, that kind of thing, right? That's a lexer. And then that generates tokens, output of the lexer, but the input to this thing called the parser, which turns a token stream into an abstract syntax tree. Basically, this just in memory and structured like a tree, where the outermost is the root of the tree, and then each level down is one level of from parent to child. So this break, you can think of it as 4 levels down. Break is in an if, which is in a while, which is in a GIF or GIF. Had to make a parser with Ruby in that class. That sounds fun. I think we invented our own calculator language. I think that's actually one of the things that this book walks you through, is making a calculator. Because one of the hardest things is actually doing, like, if you don't use parentheses in a compound expression, is to get the order of operations right. So yeah, I've already, previous streams in this series, we already did the lexer and we already did the parser. I had actually already done the whole thing in C and C++ 5 years ago, and good thing we have more people for me to explain what I'm doing to. Hey there, Stragger. We're working on the disintegrator. I have only 5 more to-do macros in the code that are left. And most of them have to do with compound data values like sets, vectors, maps. But I still need to do binary ops, and I need to do unary ops. So I'm probably going to do those tonight. But yeah, just explaining to Bathroom Homie what this is all about. So anybody who's watching Stragger, and thanks for the raid, Stragger, I hope you had a great stream. I was watching a little bit of it. I don't envy you for trying out Emacs for a month. My memories of Emacs are crippling pain to the fingers, because I foolishly used Emacs without remapping the keys, and so I was hitting Control C, Control whatever so much that I ruined my hands. You don't have pinky pain yet, but that's because you're smart and you're doing all the key remappings and your own custom scripts. You're scripting the thing. So I should have done that, but I was young and naive and didn't know what I was doing. So I hope you guys don't mind that I'm not using Emacs. I'm using Visual Studio Code. But I am working on my own language. Previous streams, like I was saying, I made a compiler for this. Compiler being the composition of a lexer with a parser, and you have tokens in the middle. You get an abstract syntax tree out. So basically an in-memory version of this program. And this program's purpose is to define the format of some data. So a GIF or GIF file, however you want to pronounce it, structured like this. And we walk in order that data structure, or this structure, alongside the input file. Like if you can actually see the header in there. The rest of it's indecipherable. But you just imagine walking through these bytes along through this structure. We're going to figure out what each of those bytes means. Very similar to the how Wireshark works. So that's what I'm working on. And the title of the stream is todo-driven development, because when I finish a task and I'm like, okay, what do I do now? It's go back to the search, to do, and I'm like, oh, okay, I should work on that, or one of these, and pick one. So in Rust, this macro to do basically will panic if you ever hit it, and it'll say not yet implemented, which is the first goal of implementing is to hit that. So we'd write a test engineered to hit something like that. And then that spurs us to implement it in order to make the test pass again, because we want to keep all our tests passing, right? We have a lot of tests now. We have 379 of them distributed between those three parts: lexer, parser, and ingester. Yeah. All right. So you guys, let me know if you have any questions. Hopefully I kind of explained at a very high level what we're doing. We're using a custom compiler to break down data. Very similar to Wireshark, all right? Which means that eventually I'm gonna have to write a GUI like Wireshark, or similar to it. The goal being that instead of showing something like this on the screen, eventually we're gonna have a nice GUI that shows this and this on the same GUI, and I'll be able to click a byte and it'll highlight like where it is in the format, which would be super awesome, right? Similarly, I should be able to like click on a data block and it'll highlight where that data block is in the file. And if we're super advanced with it, we might have like a second pass decoder that'll take the LZW blocks that are in here. Those data blocks have an LZW encoded stream, map them to actually map them to pixels, show the GIF or GIF image, and let you like click on a pixel and it'll show you where that pixel is in the file. I just think that's super awesome, fun thing to do. I'm not doing this for any other reason than to have fun and to keep my skills as sharp as I can and to entertain you guys at the same time. We're multitasking. Okay, I checked those out so I can delete them right now, right? All the tests are passing, so yeah. What's next to do? Binary ops? I suppose I should just jump right into that. So let's engineer a test that will get us a panic of not yet implemented right there, okay? So we're gonna go to the tests and make a new file. Because I'm probably gonna want a new file for every kind of binary op, right? Or maybe not. Maybe just one called ops or something. Ops for operations. Because in Rust, we like to abbreviate until no one can read the code anymore. Mod ops. All right, rather than write it all from scratch, I'm just gonna shamelessly steal from some other tests I have. I gotta go in tests. Right. How about this one? This is nice and small. Ops. Paste. Okay, so test, like, what kind of op? Like, add. This actually would be the easiest because we already have the add implementation all done, I think. And so without using any other kind of thing that's not yet implemented, how are we going to add things? How about we parse two things. So two unsigned integers, 8-bit, right? X and Y. And then we're just going to add them and return the result. So return X plus Y semicolon. So we have to actually put bytes in here. How about 42 and 69? And we're going to assert that there's no error. We're going to assert that the value is some data value unsigned integer of, what's 42 plus 69? That's 111, isn't it? Yeah. And then I don't really care that those things actually exist. We're only testing add after all. So let's run the test. The objective again is, so it was sort of the stream title is sort of a pun in a way because it's TDD, it's to-do driven development, but it's also test driven development. Because although we use the to-dos to see what haven't we done yet, to actually do it, I'm trying to use TDD. So I wrote the test first and making sure that the panic on that line not yet implemented, and indeed, if I click that, we get right back there. So that means our test is doing the right thing. It's exercising this path through the code, right? So now we have to actually have it do something. I'm going to delete that, have it fill the structure fields again. And I think just like I'm doing here, I don't want to make the match expression too long. So every match will have its own function, basically. Evaluate, in this case, binary operation, right? And then we'll just pass it the arguments, left-hand side, the operation, and then right-hand side. And I can do my nifty inlay hints to see that one's a box expression, the other one's a box expression, and in the middle we have a binary operator. If I click on that, here are all the binary operators we have to implement. So this is going to take quite a while, right? We'll want to have a test for every single dang one of these. Maybe even more than one test, because like some of them will have like error conditions, or they might operate differently depending on the types of the expressions, right? So this will take a while. Hopefully you don't fall asleep. Hopefully I don't fall asleep either. Okay. Just trying to keep things in order. Oh, I remember this. I moved all the expressions into another file, right? Or did I? Like, where did I put evaluate? Oh, no, I didn't. There just aren't very many of them. Take that back. I think I was in my head thinking, eventually expression.rs is going to get too long, and we're going to want to split this up into more than one file. So we haven't gotten that far yet. We have to put the ubiquitous self in there. These are both expressions. And you remember it said box expression? So let you in on a little secret. In Rust, a box is just a fancy thing in Rust that means a pointer to something on the heap. And we own that pointer. We're responsible for freeing it. Good thing that Rust does that automatically for us. We don't have to explicitly do it. But yeah, because box is really just like a pointer, it supports, the technical term is it supports automatic dereferencing. So by passing it, I don't have to say the type up here is a box, the same exact type that the type inlay hint said it was. It's actually a reference to a box with an expression inside. We can actually shorten that and say it's just a reference to an expression, and Rust will be like, cool, because, oh, did I do that with multi-cursor? That's sweet. Rust will say it's cool because the box supports automatic dereferencing. And then this operator was like a binary operator. This one's our own type, not box, so we're just going to type it. Binary operator. And the magic of Rust formatter formats it nicely for me. We do have to import that. All right, so let's just bite the bullet and we'll just do match on the operator. And fill in all of these things. So look, now we've gone from 5 to-dos to 23 to-dos. There's a secret. You never run out of to-dos. a good programmer on a well-structured project will never run out of to-dos because every time you implement one, you create 10 more. Just kidding. It'll happen for a while that our number of to-dos will go up and go down and it'll explode like this. But eventually, I assure you, there is an end in sight and we will get down to 0 to-dos eventually. There'll always be bugs too. That's right. Well, not if you do TDD. Just kidding. Can't maintain 69 to-dos. That would be hard to maintain a constant number. You would probably see me like going to great lengths to contrive new to-dos. And like, that might be a fun 24-hour stream, wouldn't it? If you like set the rules, you can only have exactly 9 to-dos. You have to try to implement them. So every time you make one, every time you remove one, you have to make another one somewhere. Yes, they don't work. Yeah, well, that is fundamentally a bug if a test doesn't work. But that's the kind of bug that you just fix by writing code. So right now we're doing add. Where's add? Plus? Oh, because this is an operator, not an operation. So the operator implies an operation. So plus in a binary operation is add. I think because this match is so huge, we should, again, delegate to sub-functions. And here's where I probably will make a sub-modules. So self.evaluate binary op add. Left-hand side, right-hand side. Okay, so we're going to make one of those. But we're going to have a ton of them, so let's make a subfolder called expression. And in that, we're going to have a file called I was going to say a file called add, but actually, should I have another level called binary op? Or just called add? Why not? Could reorganize this later if I want, right? Oh, I think my phone finished updating. Whoops. There's actually a bug. Mistyped my own password. Okay. Yeah, I want to start another update because, yeah. So hold on. All right. Set that going so I can do some other multitasking. I am loving Rust. I've been using Rust for about 3 years now, but I don't get a chance to program in it anywhere else but in my spare time. So that's why you'll see me almost exclusively these days programming in Rust. I'm going to be doing the advent of code in Rust. If you don't know what advent of code is, actually, it's probably my history. Yeah. It's advent calendar of small programming puzzles where you can solve a puzzle in any programming language you like, which for me, that means Rust these days. But you can see other streamers during December doing this in all sorts of crazy languages, including Squeal, which I think is awesome. Squeal SQL, if you didn't know what I meant. I didn't know you can actually solve computer problems using SQL, but Anthony writes code proved that you can do it. All right, so mod add. And in add, we're going to have the another implementation of context. And why type something when you can copy paste, right? So I just noticed something. I forgot that this needs to return a return scope. Or do we return that? Actually, I think that's what we return. Never mind. It's not return scope. Where was I? Right here. We're returning a result, which could have some optional data value, or it could be an error. So we don't need that. So yeah, we need to make sure that evaluate binary add op add does the same. Oh, that doesn't even exist yet. Yeah, the whole point was I was gonna copy this, right? Inside here, paste. Evaluate binary op. Did I shorten it here? I did. How sneaky I was. I shortened it so it wouldn't get wrapped. Op add. So we got to import all the things, right? Got to import context. We got to import expression. We got to import binary operator. We have to import data value, and we have to import error. Luckily, for most things, it just works to do the command dot and the quick fix. The quick fix is usually right. What's going on here? Listed lifetime not. Oh, that's right. It's a little bit funky now. We have a lifetime on the context, but we're not concerned about it in these functions, so we can just elide it. Elide means let the compiler figure it out for us. So to do, there's where our to do moved to. Just to make sure we're actually entering there, we're going to run our test to make sure we hit that. Oh, and the rule is that in a sub module, you have to, we did do the pub. How come this didn't work then? It takes 3 arguments. No, it doesn't. I messed that up. There's no operator. Okay, cool. So don't need that. Now that we've moved the to do, we want to make sure our test still hits it. So that was ops, yeah, and then run test. And we hit not yet implemented there. Cool. So we're still on the right track. We're still going down the code path we're supposed to be doing. Why is Anthony is crazy not permitted by default by automod? Automod, come on, man. Anthony is not crazy. He's just very imaginative. Yeah, automod is drunk. I mean, it's Nightshade Dude. Everything Nightshade Dude says should be permitted. All right, so how do we add? Well, first we have to, I think what we're going to do, we first have to make sure the expressions are evaluated, and then we want to make sure that they're the same type. And I think I'm just going to do a simple rule where the right-hand side is going to be cast to the left-hand side's type, and then we're going to add them. And I've done this in a similar place, right? Actually, I think it's just called add. Let me find where we did that. Where would that be? Statement increment, statement. I think it was statement increment. We just had it add 1 or something, right? I don't know. Let's look for the word add. With the parentheses. There, I found it. Right. Data value itself supports add, and it does the casting for us. So that's sweet. All we need to do is evaluate the expression. And then on both sides, and if they both evaluate successfully, we just call add on one side. So yeah, we did this before. I'm just copy pasting the code around and paste. Okay, so if we get a left-hand side and we get a right-hand side. Actually, I have an interesting idea. Can we just combine those two? If a tuple containing OK left-hand side and OK right-hand side equals the tuple of self-evaluate left-hand side and self-evaluate right-hand side, then we don't need to have this inner if. We're not actually dereferencing anything. Can I combine this sum value into here even? That I'm not sure about, but I can do the same trick. Actually, why can't we do that? Why don't I just like let it try to do that? So it would just be left-hand side add right-hand side. And if we get a result that is what we return, right? In fact, can I not return all the way out? Like this is called by that, which is actually I just do call hierarchy. I'm just wondering, like, when we get an error, are we responsible for setting the error bit? I don't think we are. Yeah, we just do error diagnostics. We don't actually set the error bit. So what happens? So back to the call hierarchy. Does that mean all our callers are responsible for that? Looks like it. Doesn't it? No, that's, yeah, it goes even higher up. Oh yeah, yeah, because we might not even be in the right context, so we don't want to set an error bit. Okay, cool. I answered my own question. So we don't set an error bit, we just return the error. So hold on, back to add. I think we just say return that, because that's the exact type we want. Right? Consider using expect to unwrap. I don't want to unwrap it though. There's a similar. Wait, did I call it and instead of add? No, it's because it's still an option. Oh, so we do want to make sure the left-hand side is not nil, but we only need to check the left-hand side. So if some left-hand side, I'm just thinking, is nil ever permitted in any binary operation? If so, I have to update my my add. Where was it here? Oh, that takes a right-hand side optional value. Okay, then we're good. We just make sure the left-hand side is not nil. So it's never permissible to do a binary operation with nil on the left-hand side. I think I'm okay with that. Okay, so this will just say left-hand side had better be something, else we cannot add to a nil value. And this actually, don't we just return error? Error. Then I just return left-hand side add right-hand side. And that's already a reference, right? No, it's not. Add a reference. Return. What do we do if we get an error on either side? Actually, what I want to do is return that. So there's an even simpler way to do this, right? We just say let left-hand side equal this question mark. Let right-hand side, whoops, let right-hand side equal that. And then I don't need to do any of this stuff. Okay. Make it easy on myself, right? So it's going to tell me I don't need to do return because a proper arcane Rust developer just does that. I think that's all I actually needed. And it took me a while to get there because it's been a few days since I made that add function. So actually, you know what I think about? This this is going to be common for all binary operations, right? And I probably don't need to have a special module for add. So why don't I instead call this like binary ops, and like add is just one of them. And then there should be like a common binary op that, we know we already have a common binary op, don't we? Yeah, okay. Yeah, let me rename this. Binary op. Okay. So that should change expression to say mod binary op. And then this, I should just move this, right? Into binary op. And then this common stuff, we'll do at the front, at the top of binary op. Actually, and then I probably don't need these functions because we're going to have the values do them, right? Just do that, right? Only problem is the diagnostic is going to need to be different. But here's something clever we can do. I can make something that is like, and just take op. Actually, we can just put op in there and have op implement the display trait. That way, the binary operator plus will just construct the add string. Okay, yeah, so this, I think we just do this. Super easy, right? Then we don't need this at all. Cool. Yeah, at first I had forgotten that I had delegated the binary operations into the value itself because it seemed like the closer the better. This is close to that value. It's just an enum with what values could be. And why not just implement add on them, right? Well, it looks like we already implement the display trait, but I don't know if this is correct. Can I go to binary operator and see what the display trait is? So it's actually not going to print the right thing, is it? It's going to print the plus sign. So it'll end up saying cannot plus to a null value. So what if we do another clever trick in Rust? We can make a new type. So like, how about binary operator as verb op. So this, we just need to define somewhere, and we could do it right here. Why not? So struct has a binary operator in it. And we need to derive clone and copy because it's trivial. Because binary operator implements, oh, it doesn't? Well, this should clone copy. So the trivial type, it should implement clone and copy, right? Okay, and then the final piece, which is implement display. Use standard path display. Oh, it's already aliased. Okay, so for binary operator as verb. Oh, it's not imported. I thought it was. Okay, and then it's really just a match self.0. And then here we are again with our to-dos. But I think we can do all of these, right? What is the problem here? Expected one argument, found two. Oh, because that doesn't use, that's not a macro. We have to actually do the formatting in a macro. There we go. And that has to be dereferenced. Now we're good. So the only one we really need to support right now is plus, right? So that's write f add. as a macro. Or actually, there's a shorter one if it's constant, right? We can do write format, no, write string to f. The string will be add. Use the dot operator to call it on the formatter. So it's f.write. And is that fallible? It is. So we're just returning the result. Do I need standard format? I guess so. Looks like we didn't need the write trait though. Okay. So I'm wondering if I should just fill these in now since it's super easy, and I think the answer is yes. So let's do it. And would be logically, because it's got to be used as a verb, right? Cannot something to a nil value. Really, the to should be part of. It's now it is verb, right? Cannot add something. Cannot logically. What's the verb form of logical and? Cannot apply logical and. No, it has to fit with my sentence here. Cannot apply. Cannot logically and. That's as close as I've gotten so far. Cannot logically and to something to. Yeah, I think that's fine. So this would. So a lot of these are going to be logically, right? Exclusive or. Inclusive or. I guess those are all logical ones, right? Cannot compare. Cannot divide. Cannot compare as equal. Cannot compare as greater than or equal. Okay, and then compare as greater than cannot check for set membership something to a nil value. Yep. Okay, and then this is compare as less than or equal. Left shift compare as less than bitwise mask subtract modulo. That's not a verb though. I guess maybe it is. Multiply. This is there's a logically or wait a minute. There's inclusive or what is bitwise operator or go to it. Find all references. I think I need to look at my Lexer to remember what each of these is. I can't remember right now. Lexer source output. I'm trying to find it. Okay, so OR is logical. Oh, this is bitwise, not logical. Okay, then I made a mistake. This is bitwise. Inclusive OR, this is bitwise. Because this is logically OR. Okay, then compare as not equal. Add and right shift. That actually took longer than I thought it would. Too bad this is a little bit too long. I made them all fit except for that one. How far was off? It's off by 2 characters. I can't think of how to make it shorter though. I'm just gonna move on. All right. We're just gonna go and see if it works. Where did I put that again? What's it? Why do we have a warning and expression? I don't know. It's not used. Is it ops? Yeah, here we go. So let's see if it works. Hey, first try. Add works. Let's put our nil check. So the nil check would be we have like local x or x equals nil to be explicit. And so here we should get an error. And to see the error, we have a logger. So this is like add to nil. I think we only need to do this once because all the other operators go through this common code. Cannot add something to a nil value. There we go. So we pass. Now we're what, up to 381 tests? Excellent. So we're moving on. To-do-driven development. Okay, I could do these, or I can work more on the binary operators. We did plus, right? So minus should be almost exactly the same as plus. And maybe I can even try to reuse some code between them. So let's make a test hit the to-do in minus. Ops. So I think this should be really easy. We copy the add and we turn it to subtract. And we change that to a minus. Okay, so one problem is if they're unsigned, this will underflow. So why don't we have a test for that? Underflow. We should expect an error for that, right? So assert an error. But we need to have the error. We have to know that this was the source of the error. So I think the way we're going to do that is we're going to verify we parsed 16 bits. So we're going to actually turn this one into that we get 16 if we ask the bitstream what offset you're at. Bits.borrow.get.offset. Yeah. Okay, and then let's have a positive test for add, as in like it doesn't error out. Or subtract, I mean. Subtract. Just subtract without an underflow. Okay, so then let's make the left-hand side integer. And so this should cast to an integer, which it would, and then we would get a signed integer of 42 minus 69. So that's like 69 minus 42 negative, right? So that would be negative 27. All right, let's do this first, this one. Okay, problem is I didn't turn the plus into a minus. Try again. Not yet implemented. On the minus. That's exactly what we wanted. So I should be able to say left-hand side subtract right-hand side. Okay, so let's add subtract. Yeah, see, it's we're gonna have a lot of code. I'm wondering if I should like break this down into sub functions or something. I think I am, just because it's long enough to maybe where we want to have. Hold on, before we do that, we're finishing my statement though. We might want to have a file for each of the operations, because it's by itself going to be like 50 lines of code, and the function's long enough that it wouldn't be too small of a module, right? But there's going to be a lot of commonality between add and subtract, right? We're still going to do the cast. We're still going to want to get the value as the correct type, and we're going to do. So the only thing different is this is going to be checked subtract, right? So I'm wondering if I could have a generic, or I could have a reusable function that takes maybe a functor. It's got to work with an unsigned and signed, and decimal, and string as well. Well, string's going to be different for everything, right? Yeah. So only part of this match is going to be common. So maybe I don't worry about it. I'm not going to worry about it. Instead, I am going to make another folder called value. And in there, I'm going to have an add.rs, and I'm going to have a subtract.rs. And then under value, we're going to have modules. So we're going to have a mod add, and we're going to have a mod subtract. All right, and then I'm going to move this add function. I'm going to move that into add. Okay, and I'm going to take it out of value. Like that. We're going to leave cast around there. Add, we have to make it public, which we are. Okay. What's the problem here? Oh, shoot. That should be use super value. Yeah. Okay, and then error. And the error from log as well. Cool. All right, and then binary op is broken because we don't have a subtracted. Yeah, but we can add that now. So I'm going to take what I have in add and just copy paste it to subtract. And name it subtract. And then fix things up, right? Overflow. Let's see if the word add is anywhere. I'm just going to do sub. And then we're going to change subbing to subtracting. I think that's all I need to do for, oh, no, subtract for decimals is a minus. So what will it mean to subtract strings? I think that we should just say that that operation doesn't exist. So maybe then I should move the cast into the match. Actually, if I move the cast into the match, then I can make cast generic on a type. And then get rid of these lets, right? So we won't have so many unreachables. In fact, you know what I can do is I can have 4 casts corresponding to the 4 variants of value, and it could just be cast U64, cast I64, cast F64, cast string. And then I don't have to do this kind of unwrap thing anymore. Right? Okay, let me do that next. But first, let's just have special code here to do what we want. This is just always going to generate an error, right? I'm gonna want to do what? Just an error? I just realized though, if we ever hit these diagnostics, it's printing them without saying where in the file it was, and I don't want to perpetuate that problem. If it's true, yeah. Well, anyway, we're gonna do an error where like subtracting strings is undefined. Yeah, and then we're just gonna return an error, right? And then I don't need to have a left-hand side after all. Okay, well, let's see if that passes our test now. Ops. Run subtract. Okay, that passed. How about the underflow? Underflow subtracting two integers. See, I was afraid of this. So the diagnostic says there was an underflow subtracting unsigned integers, but it doesn't say where in the program. It should say it's line, that's 2, 3, 4. It should say on line 5 that it was evaluating this statement, right? So we've lost the statement context. So we need to fix that before we move on, I think. Actually, did I have that in as a to-do? Test to ensure evaluating argument starts on the first error. Parentheses. It looks like I don't even have it on there. Well, let's do it now. So problem is in binary operation. In binary operation, we actually have a self. Then I think I know what I want to do. Rather than having it print the diagnostic inside of these functions, we can have those functions return a special kind of error that turns into a diagnostic. So that could be maybe like add could return like a string, because the only thing we're going to do with the diagnostic is print a string, right? So if it's an error, the string means what diagnostic we want. And is that going to be good enough? I think so. I think so. So then the way I would turn this around is back here-ish somewheres. See, we already have this construct, right? Yeah, I think what I want to do is I want to do a map error. So this is going to be like explanation. Or really, it's just going to be an error message, right? And we'll have a side effect of that. And then what we're really going to return is an error. Or we're just supposed to map the error, right? It's just going to be error. And this message is just going to be passed as is to the diagnostic. So it can't be an error. We have to teach this that it's not error. That means on both add and subtract, it has to say string. So now it's string. Why is this an error? It thinks, okay, did I not hit, I didn't hit save. That's why. Hit save. All right, so now all the errors are in constructing the return value. Cool, so cast probably should just also have a string. Yeah, for the same reason that it was directly doing a diagnostic. So now instead, this will be map error to a format and like that, right? That actually looks a lot nicer. I like it already. So because it's the correct type, we don't have a problem there. We can early exit. Yeah, so this should just go to a string. So this string, hold on. Yeah, to string, right? I'm going to be changing some of this anyway, right? The cast is going to do all this stuff, but that'll be next. See, all where we had to do this before, it's just make a string and do an early return. Okay, that's it for add, and we don't need create error or log error because that's now done by the caller. So same thing here. This should be just to string to string. And same thing here. And one more. Oh, this has to be an error, right? Okay. Now when I run the test, it should give me a nicer diagnostic. Yeah, see how it gives me the line number, column number now? That's what we were hoping for. So line 5, columns 13 to 26. 1, 2, 3, 4, 5. Right? 13 to 26. 13 is there, 26 is there. So it's saying that that is the context of where we found the error, in which I think it's close enough. It's going to be some expression in the current statement. And so we would just, if it's a complex statement, we might take longer to find out where it happened, but here it's obvious. All right, and then our test should all pass, right? Cool. So let's fix that warning that I saw. Unused variable error. Oh, I have an error in there. Why do I have an error in there? I don't actually think I need that error. Let's just delete it. Delete. So all these places where we have all these places where we have constructing an error, we're just going to say, let's pick all of them and delete the line we're on. Easy. Multi-cursor is cool. All right, so we have add, we have subtract for some combinations of types. I haven't tested that subtract with strings should fail, so maybe a special one for that. Subtract strings. Because this also kind of serves as documentation on what it means to subtract strings. I'm not going to bother parsing. I'll just say we don't care about the number of bits. We'll just rely on the diagnostic, I guess. We'll just make sure that it is an error to try to subtract strings. Lulls and subtract omega. You cannot subtract omega from lulls. Everyone knows that. Subtracting strings is undefined. Great. It's sort of a silly test though, because all it's checking is that we get an error. And as a side effect, when we run the test, we see that the diagnostic makes sense. Alternative would be to mock the diagnostic system. So instead of using a simple logger, we would have a logger that collects the output, and then we would assert that it is what we expect. But I kind of draw the line on diagnostics in unit tests. I think that if they look wrong, you just fix it. We don't expect that they're going to be something specific. All right, to-do-driven development, right? We're down to 21. So there are a lot of them here, and they should go pretty quick, right? Especially if I pick one similar to what we've already done. What if I pick, we did add and subtract. What if we do multiplication next? So it's going to be similar to subtract, right? Because we can subtract and end up overflowing. Actually, it'll be an underflow if you do a negative number. No, it'll be an overflow. Actually, then I don't really care. We'll just trust that it works because Rust is going to handle the overflow case, right? Multiply. We'll just do the multiply, so it's times. So yeah, what is 42 times 69? Do I still have that thing where you can evaluate an expression? So I can do like unsigned and I make that UI. Can I do like 42 times 69? So, select them all and do evaluate. Evaluate math. There we go. 2898. So that was a special plugin called Emmet. Apparently it's not called Emmet because I don't have anything installed called Emmet. So how did I get that? What extension is that in? Emmet. I don't have anything installed called Emmet, do I? I sure don't see it. Oh, it's probably included in one of these other plugins I have. Now I'm curious. Where are we getting Emmet? VS Code Emmet. It's just built in? Okay. Well, that's cool, I guess. Oh yeah, look at that. Support for Emmet snippets expressions built right in Studio Code. No extension required. Neat. I should probably learn about some of the other things it can do, right? Because look at what they had in that example there. Like it was just filling stuff in. Yeah, this right here where they did UL greater than LI times 3 and then they greater than span dot hello and it like $sign and it just filled in an unordered list. That's super cool. Hey there, Buff Siegel. I have successfully unlurked you. Sorry about that. And then Vincent Dealencar. Hello? Pre-install it is. All right. This is going to fail, right? Test and to-do driven development says, we made a test to find a to-do. My Roomba just hit an error 5 and my son is not moving, so I guess he's not going to rescue the Roomba, so I have to do it. Hold on. Error 5. Dusty got stuck under the dishwasher. My son is sitting out there and he didn't move at all when the Roomba cried for help. Yeah, poor Roomba. Roomba's name is Dusty. He does a pretty good job. But he does get stuck under things. He gets stuck under the dishwasher. He gets stuck under my son's chair. If that happens, he will move, and he will move the Roomba. And he gets stuck on certain edges of certain carpets. And I have to remember to clean his bin every time. He picks up quite a bit of lint and cat hair. All right, so we're doing like multiply, right? Multiply. So let's go to subtract. Or do I care? I guess it's going to be kind of similar because there's no such thing as multiplying strings. Oh, right. I had a separate file for each of these, right? Yeah, because we can. Multiply. Value will have a mod multiply. Okay. So that's mul, right? Checked mul. We're done. because I did multi-cursor. Ops. Test multiply. Done. We're on a roll. We'll get faster and faster as we go, right? So back to here, we're gonna do divide next, I guess. So let's make a divide test. Divide. Actually, how do we want to define division of unsigned integers? How shall we define that? So one way would be to truncate the answer, and I think maybe that's where I'll go. Another way would be that the result would be a floating point. I don't think I want to do that. I think if we wanted to do that, we would typecast the left-hand side. We'd have some kind of way to typecast it. We'd typecast the left-hand side to a float first. So then this is not going to be an interesting division. So let me pick like 42 and I don't know, 8. So we should get 5. Okay, so run that unimplemented, right? Unimplemented. Left-hand side, divide. Right-hand side. Take multiply, copy paste, rename, divide. Take multiply, change to divide. Dividing is no E in it. Mul is div. Done. We need mod divide. Bar right-hand side. Run. Okay, moving on. Let's do modulo, because it's the same as divide, only different operator, right? Modulo. So that should be 2. Gives us the remainder, right? If I use the modulo operator. Okay, yes. Yes. Doesn't that kind of act funny when one of them's signed? I won't worry about it now. Okay. Divide, copy, paste, modulo. Value has a modulo. Divide globally replaced with modulo. Or is it modulus? I don't know. Dividing should be still dividing. Actually, a check div doesn't give us an underflow, does it? Check div. Does that ever panic or return an error? Only if right-hand side is 0. Yeah. Makes sense. So it's not really the right diagnostic. So we really should say hold on. First, what's check div for integer? Or if the division results in overflow. Well, technically dividing by 0 gives you an overflow, right? Actually, how could dividing in assigned integers overflow? That's how it works. Oh, right. because you can't flip the sign on the minimum sign value because there's always one more negative number than there is positive, right? So that's the only way you could so I guess overflow is the correct term. Then we're leaving it the way it is. And we're just changing this to do a mod. There is no mod, checked mod. Okay, how do we get a checked modulus? Is there even a checked modulus? Maybe it doesn't matter. It's always valid. Well, what if we do what's 1 mod 0? Could always run it and see. How mul abs negative. I'm just looking to see. Oh, it's rem. Rem for remainder? Yes. It's rem. Check div, check rem. Dividing strings is undefined. Oh, you know what? We copy pasted the subtract to multiply and divide, right? Module. Actually, can you do modulo for floats? What does that actually mean? Does that mean something to modulo floating points? I guess we could see what does checked remainder do for F64. There is no checked remainder for F64. So what does it mean to ask for the remainder for float? Read more. Okay, but what does it mean for float? I guess we can look at the source. It doesn't say. Oh, here we go. The remainder from division of two floats. The remainder has the same sign as the dividend. Is computed as x minus x divided by y truncate times y. See, look, they even have nice examples here. Okay. I mean, it's sort of like what you'd expect, right? Cool. All right. I'm happy with that. Divide should be divide and multiply should be multiply. I'm kind of cheating. When I find a bug, I'm supposed to make a unit test, but I'm cheating. I probably shouldn't. I should have tests for adding, subtracting, dividing, and multiplying floats. At least the positive case, right? Yeah, I should just do it. I shouldn't cheat. So let's just go from the bottom up. Modulo decimal. So yeah, I'm not gonna do any parsing. So let's do like 1.2 and y equals 3.4 and modulo. Well, it should be the other way around, right? Or a bigger number here. How about 12.5? So we don't need any bits. Should get decimal. Whoop. Decimal 12.5 mod 3.4. Emmett, please tell me what that is. You fail. How about divide? Actually, I can just plug in this, right? Maybe not plug it in, but I can first have it calculate that for me. Okay, that's an ugly number that I don't have to deal with. How about we use like something that gives me a nice number? That's not a nice number. 3? I hate using actually, why not use 3? Because of that. Divide by 2. Okay, we're gonna do divide by 2, because this also tests the upcasting, right? So we should get 6.25. So that would be 6. 12 minus 6 times 2. 12 minus 6 times 2. Isn't that's 0? Wait. Did I not understand that correctly? No, it's 12.5. So it's gonna be it's gonna be 0.5, right? Yeah. And then while we're at it, let's do the divide, because we already know that's going to be 6.25. Right? Well, let me just type it again. I am bad at math, so I'm going to let Emmett do it. 6.25. So that's a divide. This is divide decimal, and let's do the add and subtract. So subtract 10.5. Add 14.5. Okay, let's just run them all. First try, right? Nope. Modulo, modulo decimal are wrong. Not yet implemented. Yeah, to-do driven development, right? Modulo, but I did that one, right? I just forgot to type it in there before. Yep, first try. I like first try. Down to 18. Yep. Cheating is okay sometimes. Most of the time when I say cheating, I'm not really cheating. It just feels like cheating sometimes. Okay. This is actually getting a bit tedious. So I could go off and do something different, or I can just power myself through this. So generally speaking, we have like 3 categories of things, right? We have comparisons. We have bitwise. And we have logical. Like or and, right? Logical, comparisons, and bitwise. Oh, and we have set membership. So this one's probably going to remain a to-do until I have sets I can test with. Oh, Dusty's done. I heard the Dusty victory sound. Left shift and right shift are odd, right? They have weird rules. Comparisons, maybe? Comparisons aren't so bad. Let's do the comparisons. So the first comparison we have is the equality. What am I doing? Test first. No more getting trapped into that pesky washing machine. That's right. Equal. This is going to be sort of lame. I kind of need 2 tests, don't I? Actually, what if we ran it twice with 2 different bit streams? So this would be, oh, what type should I use? What if I just invent a new type, Boolean? Because why not, right? Because it's going to make my life harder. Because I'll have to be able to, like, I'll probably want literals for true and false. And they'll have to support casting to and from them directly, right? I sort of already do though, right? Yeah, I remember doing this in value. We have a try from for bool. So this is the conversion to bool. So it wouldn't be too bad because we could leverage this for the cast stuff, which this cast stuff, cast a signed integer, cast a unsigned integer, cast a decimal, cast a string, which is called from where? From cast. So yeah, if we added a Boolean, I would just do cast to Boolean and that would leverage the try from. So maybe it's not too bad. It's something different and maybe a little bit interesting. So let me complete the work I was doing to make that test. What I was thinking is that there would be like a data value Boolean, and this would be false. But then we could just do it with another bit stream. Actually, I can just use the same bit stream. So I could just have two more numbers, 50 and 50. And then when we ingest it again, this time it should be true. So there's no Boolean yet. So let's make it. I should sort these, shouldn't I? Okay. Right, so we're gonna run into like problems everywhere. This one's easy. It's just okay, B. Okay, dereference B. Okay, try from value. So to U size, right? So that's just going to be 0 or 1. So B, then if B, 1, else 0. Okay. I wonder if I could just use the U size from? Let's see if it actually just works, right? If I do a U size from B. Does that actually there's a from bool since 1.28. But it's in a macro. It's kind of hard to see it. Converts stringify. I don't see the actual code. Is it impl from? It is, right? Impl from. Okay, here it is. It's hard to see it. Is it in the arguments that I just didn't notice? From bool. 0 for false and 1 for true. That's actually what I want. So I think I'm cool with that. U size from. Okay, moving on. Boolean B. How are we going to write it? What happens if I do write and is there a display trait for Boolean? I guess there is. Can I look it up and see what that is? Never thought about this stuff, right? Like, what's the implementation of the display trait for bool? Display. I guess I should hit source, right? True, else false. Works for me. Match self. This is cast. Right. Can I use the try from bool? The error is error, so it doesn't quite match, does it? Cast to bool value. We'll just have to make one of those. How come it's not helping me? Okay, I guess I have to do it by hand. Sum value boolean b. Okay, what do we do for casting to an unsigned integer? That's just okay, value value unsigned integer, and then it's b. We'll use 64 from b. Why not? Okay, sum. Dereference b. Getting there. I should just be able to copy that. Actually, for signed, it's just I64. There's no I64 from boolean. No, signed. Okay. Decimal. Is there an F64 from boolean? There is. Really? 1.0 and 0.0. I mean, I guess so. That's sort of stretching it though, right? Cast to string. Yeah, I guess we're just doing to string. That's just going to be, again, true and false, right? True and false. Okay, so I'm just missing a cast to bool. So let's copy from cast to string, I guess. Oh, wait, no, we can use the try from. So, yeah, we really want to copy from here then, right? Just copied this. Okay, cast to bool. Boolean. I don't think I actually do need to do a match. I think it is just going to be, hold on, this try from. Only it's going to be some value. And then we have to handle the none case. I think actually the way I want to handle a none case is it just goes to false. So that means that this is an okay. Actually, if the other one's always going to cast, then it is just a value that we get out after all, isn't it? So it means we can cast anything to a bool. So if it's some value, then it's going to be bool from value. and none goes to okay. This has to be encapsulated, doesn't it? Actually, we can just encapsulate it outside. I'm thinking that actually this is going to end up being reduced quite a bit. Is it try from? But then unwrap? What's wrong with this? Do you reference that maybe? Yeah. So it's leveraging the try from here. Oh, there is an error we can sometimes get, right? Oh, but it should always be okay, right? Hold on. Oh, right. If it's a string and it's ambiguous, we can get an error. So it is possible to get an error. So I need to undo a bit. Well, let's copy what we have here so far. Undo a bit. Tell you the return value is there, and then I'll paste here. So instead of unwrapping, I think what I'll do is just do that. And then don't I need to like map the error? This already maps, well, so we have to put it in an error with value types. Okay. I'd rather do it this way. I have to, well, hold on. If I put this into an okay and do an early return, will it actually map it? No, it won't, right? So I have to like do a map error. And then do a paste, right? From Boolean. So I don't need this line anymore. Reason incompatible types. Thought that would work. No more getting trapped. Oh, yeah. Never mind. I'm just reading that twice. Option. Yeah, it's always going to be something, right? This is just to make the caller happy. Okay. Oh, shoot. Yeah, that's a problem because before I would always have the from. Yeah, shoot. It's the to is that, but what is the from? That's static. I think there's like a to-do about this, like somewhere. I don't know where it is, but like there should be a way for me to get a from the type. Do I already have a function for that? I don't. I have that error. Okay, I think I need to reorganize this code a bit because like there's some redundancy here. Like, and that should be derivable from that. Okay, hold on. What first things first? So the reason should be this E to string. Oh, this actually just returns an error. Okay, never mind. That's bad. Because it's going to print an extra diagnostic, and I don't want that. Because we'll get something twice. It's making me want to copy paste this, and I don't want to do it. It's just that this is structured differently. The error type is different. Can I see where the references are to this? Okay, I can actually find them all. I'm not even using that error, and I'm doing another diagnostic anyway. So maybe I shouldn't even do a diagnostic from inside the try from. And then maybe print a diagnostic here instead. Because, okay, I'm inconsistent. I do a diagnostic there, but I don't do one here. And I don't do one there either. So what? That's what inside of evaluate. I remember why. Because we didn't think we... Well, this one I should have done a diagnostic. This one I think because we were inside the... Oh no, I should have been able to do one there too. I think I was just lazy. Oh, that's because that's copied from here. Yeah, right. Okay. Copy paste problems. Oh, I remember this now. That's because this doesn't have knowledge of what alternative number we're in. The which. Okay, and actually that since this returns a result, I didn't want it to print a diagnostic anyway, so it really shouldn't have done that. It should just return out this error with value types, right? Yeah, we should just have it do that. There. And maybe even for this one as well. Maybe. What am I working on right now? I am working on basically an interpreter for a language that takes formats of data. Like here's an example for whether you pronounce it GIF or GIF, it's the same format. This is compiled into an abstract syntax tree, and then we walk that data structure and apply it to some data to parse the data, very similar to what Wireshark does. So what I'm working on right now is filling in all of the parts that are still yet to do, and we're doing binary operations. So some of them have been done, but some of them haven't. So a unit test will explain it pretty well. So here's where we're testing that modulo 2 decimals work. So here's a program in the language that I came up with. So it's very simple. These are just creating local variables and assigning a floating point number and a fixed point, a fixed integer, right? And then we're doing the modulo operation, and then it's always in 3 steps. First, we compile this as a format. Then we create a bit stream with some bits in it. We don't have any bits in it because we're not actually using them, but other tests would. And then we're ingest takes the bits and the AST and the format name, and it walks through this structure along with the bits to produce the output data component, which represents an instance of this from data. But we're just using this right now to compute. It's like a free function. We're doing math, right? So an example where we might parse would be here. Like if we have this byte string, and it says whenever you parse a foo, you take 8 bits and you interpret it as an unsigned integer, do it again, and return if they're equal. So the first time we run it, it's going to be false, but the second time we run it, it's going to be true. The code, you're like, ooh, is he making compiler? Yeah. We made the compiler. Now we're using the compiler to walk a string of bits. So this string of bits, we walk through it using this format. And we get back a data component, which tells us what format it is, where it was in the bit stream, what its overall value is, so whatever the return returned, and if it parsed successfully or not. So for something simple like this, it's trivial, and we use trivial things for unit tests. Something of more substance that is useful would be like we showed here, right? If we were to parse this with a GIF file, it would tell us with the error flag whether it actually matched that format. And if it did match it, we would be able to go and look at the structure of the file by just navigating that. How do I get that again? This component structure. So a component has keyed children. This is a dictionary of components. So given GIF, we could look at its header, and then in the header we can look at the signature and version number. In the logical screen descriptor, we can see what the width and height of the image is. By data, since it's in a loop, will be a vector, so we can look at all the data blocks just by iterating through the vector. So and that's what something like a data dissector and Wireshark does. It takes these bytes and it kind of the first top level is it finds out where the packets start and end, right, by parsing, or it just maybe depending on how the bytes come in, maybe there's a length prefix or something. But anyway, it figures out where all the packets are, and within each packet, it figures out where all the protocol layers are, and then each protocol layer has fields, and it'll be if I were to, my equivalent of that would be you get one huge or you get one huge data component out, which represents all the packets, and the top level will be like just a while loop, and then we'd parse the packet, and so you do like stream.packet and then index whatever would pick a packet, and then within that it would be like .ethernet.hardware size, and we'd get 6, right? That's what we're trying to do. I broke something. Oh right, yeah, because I was trying to introduce this Boolean type, and then so I had that, and I had the brilliant idea of, hey, let's stop and add Boolean, and I broke a bunch of things. No, it says Wireshark alternative, and we're just doing it for fun. Wireshark I use as a specific example, but mine's more general purpose. I could use it to parse packets off of a network card like Wireshark does, or I could use it to open an image file, which is this example, right? If we knew it's a GIF format, we would open it as an image file. You could even conceivably, I could make a higher order format that first does look-aheads like this to like try to guess what kind of format it is. And it says, oh, if it looks like a GIF, then parse it like this. Else, and then another block, maybe it would look for a JPEG signature. And then if so, parse it as a JPEG. So then you could just drop any image into it and it would say, it's a JPEG. Here's its width and height, etc. In fact, that might be a cool thing to do in this stream. Once I get the GUI in there, we'll try to make a super format which captures all different kinds of image formats by doing look-aheads to guess the type. So some files are super easy, right? A GIF file always begins with GIF. So we just do a 24-bit look-ahead and say, does it say GIF? Okay, then parse it as a GIF file. Else, like, I don't know what a JPEG file would look like, but maybe it starts with JPG or something. Some formats are going to be harder because you might have to parse a whole bunch of bytes in and say, does it kind of match the format, or are we parsing successfully? Like, or do we see like a signature in there that we can know for sure it's a certain kind of file type? Might have to do that, but yeah, conceivably I could have a higher order of this kind of like, it would be like image, and part of image would be like look ahead as a string next 24 bits if s equals GIF, then we'd have to have this in front, by the way. then GIF. Else, and then you can kind of see where it would go. We would put more stuff in here to have support for other file formats, right? Or maybe in the bottom of the else we would say like error, unable to determine format. So this would make a fun thing where like we drop in any kind of image file and it would tell us it's a GIF because that matched, right? In fact, I'm going to save that because I think we're going to end up using this. I'll just have to have like an else if something for JPEG, right? Back to the problem at hand. Booleans. Value. Right, I was changing the error type, right? Yeah, because I didn't want the trifrom to actually print that. That should actually go into this. Let's promote this to the top. I think that should go in the top, right? Or maybe not the top, but how about like, actually, why not the top? Error with value types. Yeah, so result. We would do a map, right? This is not actually going to print anything useful, is it? So we should actually, this is the only way to get an error, right? Yeah, so why don't I just put it in there? Oh, right. Well, this is from string, right? Actually, I think in addition to doing this, I want to also have another function that can like turn a value into a diagnostic. So that would mean that I have like another impl for value, right? Called like pub function like describe type or something. Yeah, describe type. And it's going to always generate a string. And it's going to do that by matching self. So a Boolean, we don't care about any of these except S. We kind of wanted to print the string, right? So all of these would be of the form like some type, like Boolean to string. And this would be like decimal, and this is like signed integer, and this is unsigned integer. And this other one is kind of sort of special because we can use the format and say string escape, and we can put in here like the S. Because that's what I've been doing in these other functions up here, right? Like, yeah, string S, right? Because there's repetition. I don't want to have to do that. So I wanted to have a common function that does it. And now we do. It's called describe type. So the cool thing is that now I can just say, if we get an error, I can just map it. Map the error, and then so like we could just say the error here is empty, and because we don't care about the error, we really want it to go here. Fill in the blanks, and then yeah, we're not going to do a diagnostic anymore. I don't think it makes sense. What's wrong with this? Expected enum result bool found unit type. Do I have a semicolon at the end? No. Oh, because there's a let result equal. Get rid of that. There we go. So here the two, actually we could even use oh no, I can't. I was going to say we could use that describe type, but that only works with values, not types. So we'll just have to hack it in here, right? So to string, to Boolean to string. This one though, I can say value dot describe type, and the reason could be oh, let's put the reason here. That way, we can say it here. The reason is like it'd be something like unable to determine if value indicates true or false. Something like that, right? Oh, this is supposed to be static. What's wrong with that? Oh, because this has to be toString. But I could put toString here. Well, but yeah, let's just do it here at the source. Okay, so then so this is just going to give us our nice type right away, and should probably do the same thing for this one too, right? So we're going to have the same kind of thing, only it's mapping to a U size. And we can get rid of result. Yeah, I think we are going to use this, because why not, right? It's very descriptive. Don't need this result. I just have to actually put something in here. Actually, that's what I wanted to do anyway, right? Because that reason is try from int error. What is that? I don't even know what that is. The error type return when a checked integral type conversion fails. Oh, and they have a display trait for it. Okay. Well, we can turn it into a string, right? So we just say reason to string. Yeah, there we go. Because I just want a string. Same thing here, right? So actually, that we can collapse to string to string. No, it would have to be like reason, the actual type colon, or the actual type as toString string. So yeah, this is probably best. So here, what do we want to say? I want to actually encode that, don't I? So I want to say like something to string. What should that something be? Something like converting decimal to usize is ambiguous, because it could be round floor, truncate ceiling, yeah, all that stuff. And this, again, we have a reason, right? Don't we have a reason? What's the error here? Cancel. Type annotations needed. Really? Just that one? Is that because parse gives us some kind of generic error? I was really hoping it could figure it out. This should be to usize. What do I put here? It depends on what parse is for usize, right? thing is we're ending up in a trait here. What does, let's go back. The use size, the implementation of toString or something like this, right? There's a blanket implementation that uses display trait. Implement anything that handles the display trait can be converted to a string. Actually, oh, wait a minute. I'm confused. What were we doing here? It was parse, not toString. It was parse. I want to see the parse and not this one. Let's just look up parse. String parse, right? So F, or F is from string. Yeah. So it's the use size from string that I want. From string for use size. How does that work? So there's a parse int error. Is that not, that doesn't implement to string? Well, it does. It implements the display trait. So I just need to say it's a parse int error then? Parse int error. Sure. Why did it need the type annotation? Is it just because of something down there? Weird. I don't know. We'll figure out why. I normally don't need type annotations like that. I don't even know where it was around here, right? Yeah, I don't think I need that, but it looks like it's insistent that I do need it. Oh, we'll keep it in there. Okay, we're good. And then I guess all of these I'd like to refactor them now. Yeah, this stuff here, I'd like to move the map error out like I was doing. Oh, this is relying on the inner ones to do it for it, right? Yeah, so that's fine. But so here I want to move the map to the outside. And the inside will just be the reason. So if this already is a string, then I don't need to map that error, right? Oh, no, I do. I just need to do the toString part. And this one, it's error, this to string, right? And here it's short enough now we can do that. Cool. And this thing is also a toString. See, it's this removing this redundancy I want to do it. So now oh no, this is just error incompatible types, right? And then map the error. So this is a reason. And there's no why is this? Oh, right, because that was copied from above. So this actually turns into not a let, but that. And the from is value dot describe type, right? It's not helping me. The 2 is unsigned integer. And reason. And we don't need this extra punctuation. Okay, now that it's gonna help me. What is it called? What? Oh, because it's an option. Shoot. Shoot. This is harder. I can implement it for option, right? Maybe if I have a helper trait. Dang it. It's easy to implement a function for a type, but it's harder to implement like a function for an option type. But I can do it with, I had the trick where it's like for option. Yeah, span helpers. This trait trick, right? Yeah. I'm just gonna copy this. We're gonna put it up here. And where to put it? I don't know. How about here? Well, no, let's put it at the end. We'll call it value helpers. So implement value helpers for option value. And the trait will be describe type. And this would be, this doesn't need to be generic, does it? It's just self. It's going to return a string. Actually, then I could actually implement for value and option value in the same place, right? Because I have that described right here. Why not have it implemented by the same thing, right? So this is the implementation of value helpers for value. And I don't need to say it's public. Has the same signature. And that should just work, right? So then this is match self, like this. Some value, it's value dot describe type. Otherwise, none is nil to string. There we go. I did it. So an optional value, it's nil if it's nothing. Otherwise, we do the other, the inner one. And the describe should still work, right? So this, I should still be able to say describe type. Yeah. See, now it works even if value is an option. Cool. I love it. I love it. So that was cast to unsigned integer. So same thing for signed integer. So I do the additional map to error. I get rid of the, I don't need that. That 2 actually just moves to there. Right, and then these just get reduced. Right? Just give me the reason string. That's fine. Okay, this, I just want the reason string. So that to string. Remove the punctuation, hit save. Okay, so again, just string from the error. This one's just incompatible types. Okay, good. And then same thing for decimal. Yeah, getting there. Decimal. And then that's just that. Incompatible types. Okay, and then cast to bool. So, right. So this is the one that's all screwed up, right? So now it shouldn't be screwed up because it's really just a formal name for saying that, right? So can't I just say this then? Bool try from, but then we package it into okay some, yeah, so it's just that. And I don't need to map the error anymore because that's actually what we get back. But we can do an early return. Right, exactly. And get that, and we're done, right? trait from option value is not satisfied. Oh, did I do from value but not from option value? So that's easy. I just do a match value. And there are two arms to it. It's either something. If it's something, we just do this. For none, I think we already said it was going to be false, right? There we go. I did it. So if it's nil, it becomes false. If it's not nil, we just use the try from up here. I like it. And no errors here. So I just need to track down the other errors. So I should have modified the stream title to say to-do-driven development. It says that now, right? It should say to-do and error-driven development. So if we have no errors, we look for to-dos. But if we have errors, then we're basically being driven by the errors. So what's this error? Right, we're trying to, so I need to like map this to the error, right? So that's easy. Map error. We don't care what it is, it's just error. I'm eating the error. Expected to take an argument takes 0. Yeah, we're just eating it. But then that reminds me, like, we're not printing a diagnostic then, are we? It depends. No, we shouldn't because, well, actually, wait, let's see. What calls determine limit? That calls determine limit, which is called by build part, which is called by this one, which is called by that one. I forget now, like at what point are we supposed to print a diagnostic? Do we print it right as soon as we can? I don't remember now. Like the fact that we're eating the error suggests to me that we should have printed a diagnostic there. Yeah, I think actually as a side effect here, we should print a diagnostic. But maybe not. So maybe what I do is I put a to-do here. And I say, do we need a diagnostic here? Because we can add that at any point. Why add it when we don't know if we need it, right? We're just following the errors right now. This wasn't an error before. Oh, it's already a reference, right? Oh shoot. We convert from value, but not a reference to a value, right? Yeah. Can I do an implement try from reference value? The value is copy though, right? It's clone but not copy. Right, because it can have a string in it. Can I implement from reference of a value? Looks like that actually fixed it. I just have to take a reference, right? Yeah, no biggie. We do references. Okay, match value. What's value? Local. What's local component? What's the problem here? Missing arm. We're not covering Boolean. And yeah, it's one of those where it can't autofill it, so I got to do it myself. Actually, decrementing a Boolean isn't supported either, so we'll just say some Boolean be decrementing Boolean. Oh, here's where we can use a catch-all rule. We combine these. Yeah, exactly. This to do. We can do this right now. We can say the catch-all rule, which is some value, and we can say, "Ooh, this is going to be fun," because we can say this. Error decrementing, and then we can actually put in the type here. We can say value dot describe, or I guess I didn't make that public. So we need to fix that. But Oh, probably need to format this. And probably doesn't help that I don't have punctuation there. All right, but look at that. It can handle, it's like a catch-all case. Oh, I can do it if I pull in the value helpers. Okay, let's do it. So use create data. Is it not? Is it? Where is it? Data value. Oh, do we not re-export that? I need to re-export that, I think. This stuff, right? Hold on. Actually, it told me what it was, right? Create data value helpers. Create data value helpers. It's private. Okay, so let's make it re-exported. So that means I just go to data and I do pub use value helpers as data value helpers. Easy. Easy, easy. Okay, so this has to be a reference now. This needs catch-all. Oh, and we had one. Where did we do that? Here. So it's just copy pasted, right? So this just replaces this and says incrementing blank is not supported. And I'm guessing we have one more of those. That's why I see an error down here. No, it's different. Okay, so for this, that's just a borrow. That's what that one is. Okay, so there are a couple more places. Uh-oh. Is that what are we borrowing? Something on 294. The local. Value come from local? Yes. So I have to describe the type first, and then so let type description equal this, and then use type description. This part. Right there. Hey, fixed it. Easy. One more place for that, right? So I just need to say decrementing and delete all that. All right. We have a warning that we never used that. Delete it. Done. 10 errors. Okay. Why is it trying to drag? I don't know. Adding booleans, I guess. What does it mean to add a boolean? It doesn't mean anything, right? So what do I do in add? Maybe the same thing as I do in for like divide for strings. So something like this. I would say like adding booleans doesn't. Adding booleans is undefined. Probably all of our operations that have like booleans going to be undefined. So like dividing booleans is undefined. Again, dividing booleans is undefined. multiplying them undefined. If I ever want to define them, this is where it would happen. Subtracting booleans is undefined. Okay, statements got errors. Errors upon errors. Error with values is private. Oh, we don't care about it, right? So, but I should make it public. It's public, but what are we doing? We're gonna want to also make the things inside public, right? And that means I'm gonna want to re-export this from data. Data. Well, error with data values. An awful name, but that's okay. We'll survive. What? No errors? Really? So does that mean I can like run my unit tests again? Yes, and we're failing equals. Failing equals. It's easier to just go here and type it, right? Maybe not ops. Here. How are we failing equals? Not yet implemented. Oh, here we're back to here again. Yeah, okay. We're back to where we sidetracked to add Boolean types. Now we're back to here again. Okay, so it would just be left-hand side. Actually, why don't I just leverage Rust and do like left-hand side dot compare, or just left-hand side equals right-hand side. And it'll just say like partial equal is not implemented. We can just implement partial equal, right? Except for that we need to support errors. So partial equal doesn't support having an error. So maybe I just do dot equal. Why doesn't it like my divide now? Probably because equal isn't declared. All right, we're making an equal. It doesn't really matter what I copy from, right? Just as long as value has mod equal. Okay, and then EQ. So we're gonna cast the value on the right-hand side, and then for unsigned integers, oh, I was gonna overhaul this, wasn't I? I was going to like move the cast inside and use what is it? Different cast functions that return the value inside directly. Yeah, I want to do that before I get too far, but we can do equals first. Yeah, Yeah, it's just it's gonna get Boolean, right? And it's just gonna be Boolean LHS equals RHS, right? So I have to do dereference there. Okay, same thing down here for signed integer and decimal, same thing actually. String, same thing. And Boolean, the same thing. I have to do this though. Boolean. Okay, then back to ops we go, run the test. Cool, pass all the tests. Now I can do some of those things I just delayed. Okay, one of them was all of those cast things, right? Everything that's calling cast. I wanna improve on that. So yeah, it's only done in these functions then, right? So what's cast look like? Yeah, I was gonna change this anyway, right? And really, is it only called from those places? I guess so. Okay. So then don't I just want to break this up into 5 functions? Like, we're always going to know the type of the value because it's always called from a context of knowing. Yeah, I think we just want to break this up. So it would be like, well, we already have them like that. Yeah, except for we don't want to use option value anymore, right? We want to use like cast unsigned integer should just be U64 and remove all this veneer, right? Yeah, I think that's, well, how is this used though? Call hierarchy on that. It's just used for cast. Okay, then this is easier, right? So we get rid of cast because we already have these other levels. And they already have error with value types. And the only reason we're mapping them anyway is to do a diagnostic, which we could do inside here anyway. We're already doing a mapping anyway, and here we could do the diagnostic. Actually, Oh, the reason we were doing this at all was to get a string. Okay, look, how does this work again? We're getting a string out of that because of why? Because that wanted a string to do the diagnostic. Because at this level, we're in context and we can print the statement. Okay, I got it. So here we could actually get the full error with reasons, right? Oh, except for sometimes the reason is just a string. Like, what was it? Like modulo, yeah, you could just have that as undefined. Okay, so we'd inside of here, the cast, we would want to reduce it to a reason string. So yeah. Is there any reason that this shouldn't just return a string and we don't have to expose this error with value types anymore? What? Hold on. Did I not have to re-export that? What if I comment that out? Oh, we didn't need to export that? Well, wait. I thought I did. Okay, delete it then. So it still builds. Okay, never mind then. It can be a private type, right? Or is it because I marked it as public? So if I don't mark it as public anymore, what breaks? That breaks Y. Private type and public interface, we're leaking it where? It doesn't say where, does it? It just says it's a public interface now. Do I get a folder diagnostic here? Clear, cargo, Clippy. It doesn't actually say, it just says it's on the public surface. It doesn't say. Why is the dog growling outside? Hold on a second. Maybe she wants to go outside. Yep, I think she was trying to tell me that, Raimo, I need to go to the bathroom. Okay, it's 10:30. I should probably, when I get this step here done, should probably call it a night and then come back at this tomorrow morning. Oh. Okay, so the reason I wanted to use this type was we encapsulate what the original type was, right? So, and that's because I wanted to use that down in here. Right, it made that one super easy. Okay, here's the point where right now we're turning it into a string. But if we're really collapsing this, that means all of these will we'll just turn it into strings. So I'm still trying to understand, like, why did I make this type in the first place? Well, now the doggy wants back in. All right. I feel like I'm just kind of going back and forth on what kind of error I want. So if it is, I think maybe I just want string here. And I don't need to do this, right? Because we kind of already know that. We're not going to go through a generic cast function anyway, so I don't think this is actually needed. Yeah. Same thing here. String. We still want a string because we want to be able to say that, but I don't need this map after all. Okay, so then down here, these individual cast functions, right? Right now, call hierarchy. Cast is called by all of these. So there are all these different places. Right, so at this level, it's going to be cast to Actually, no, we want, right, these are gonna move into here, and so it's gonna be like cast to unsigned integer, and then I think it cast to unsigned integer does have to say what the from type was. Mr. Balrog, hello. I had a Russian Uber driver the other day. His name was pick up and drop off. Okay, Mr. Balrog. We'll accept that one. Here, have a useless internet point. It rounds you up to 60 anyway. Nightshade Dude wants to ban you. Watch out. There is some value in having this done in one place, right? So, wait. We already have to have matches for different types. We're already going to... We won't need the to information at least. Right? We won't need that. It would be useful to have that. So I guess we would still have this type over here. Not here. Like in add. It's in a submodule, so that's fine, right? Where's this? Yeah, it's available to the submodule, right? So then it's already returning a string. Dude, did I implement toString from this? Actually, if this is only used in type conversion, then I could make a error converter for it. Right? Find references. Yeah, it's all used within here, within value. And actually I already have it all implemented. It's right here. Cannot cast blank to blank. Okay, then I kind of want to have the to field in there. That makes me think that each of these cast functions should stay as they are. And we hard code these. Yeah, okay, I think I've convinced myself. So then really, yeah, this cast is going away anyway. Maybe here's where I just repurpose this. So this is not implementation of value. This would be like an something else. We're repurposing this, right? So cut, and we're putting it up here. So this is like the implementation of how is it? It's like from error or something. From error. Or it's described an error, I think. Somewhere here, interfaces for working with error. Traits. Like to get is it try? To use the question mark operator, right? That's not it. Core ops? Standard ops? Try in generic code. Maybe they talk about it in error. Errors must describe themselves through the display and debug. Maybe it was just the from trait. So then, like, I think that is right. We would just implement from this for string, right? And then this body, it would be here, right? Let that equal the value. Yeah, sure. And that's it, right? So then I don't need this anymore. Could delete it. Okay. So I think that makes string error with value types convertible to string. Okay, and then just chase the errors, right? So what do I do for this one? One of these map errors? Boolean. And just do that. Actually, I guess it's hold on, how do I do this in other places? Then yeah, I just remove the question mark, right? Hold on. Then why is this oh, because it should just be a result option. Is the type not result option? Result option. Yeah, what's the problem here then? Expected type bool found result? Why is it expecting a bool? Oh, shoot. Yeah, dang it. I have to do a map. So it's like that goes outside there. Map, I guess, B to OK some value B. Okay. Then what's that? Incompatible types. Result. No OK there. Okay, got it. I did it. I did it, chat. Okay, so then yeah, so then all these casts actually move inside, right? So that moves in here and it's a let actually it's gonna be a map, right? Or no, if let error. No, then it's gonna be a match. Match self.cast to unsigned integer. And then how did I end up there? I don't know where I am or what I'm doing. What heck? What the heck? It switched over to value somehow. Okay. Anyway, actually I want to use the question mark operator, right? Because it's convertible to string. So it should just be, yeah, it should just be let RHS equal self cast to unsigned integer value question mark end of story. Get rid of that. Oh, there's no, it's not self. It's just cast. It's valued. Hold on. How does it work? It's a free function. Why? Oh, because it could take an option, right? So hold on. And then RHS's value is an option. Oh, yeah, so shouldn't that just work? Hold on. Cannot find function. Oh, we have to import it. Yeah. Okay. Import supercast. Yeah, import supercast. Got it. So that type is an option value. No, I want to change this then because it can't be an option value. In fact, I want this to be an U64. If we can't get a U64, then we have a problem, right? Yeah, it doesn't make sense to have an option. So this should make it a lot simpler, right? This should just be that. It's basically stripping it off, and then I don't have to do the map anymore. Expected U64 found a result. Oh, I do still need an okay. Okay, good, 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 good. So then, yeah, I just get rid of the map, right? Yeah, perfect. Except it still says I have an error somewhere. Right here. Try giving an explicit type. Why does it need a type again? I needed to do this before, right? E colon space. Why does it need an explicit type there? Is it the other errors that we're running into? Let's look for parse map error. I think I left the other one in there anyway. Yeah. For some reason, we're having to give a did I put a type to do it? No, I didn't. So for some reason I'm having to disambiguate the type and I don't know why. Okay, maybe it's because of this. Yeah. So that should just be that. Is that the reason? Can I remove this now? The answer is no. Okay, so we'll have to come back and see, like, is it one type inference because of the other errors? Maybe. Shouldn't need, it should, is type inference not work because of the other errors? I'm thinking maybe. Yeah, so then this should be a lot simpler, right? It's just cast to signed integer, import that from super, and then I get rid of all this stuff. What? Oh, this is returning the wrong type again. Yeah, we gotta fix all these. This is I64. Okay, and then we don't do the map. We remove the sum value. Remove the map. And then I have to put in parse int error for some reason that we don't understand yet. Remove the sum value. Yeah, the fact that it's making the function smaller makes me think we're on the right track. Okay, was that it for add? Wait, why does it actually work? Why did that work? I don't think that should have worked. I think the other errors are obscuring things. Yeah, we'll probably come back to add. I don't think that's correct. So paste. Yes. Delete that, copy that, paste that here. Put a signed. Import from super on both of them. Okay, copy that line. So it's just, we're just hitting all of these files that that we wrote. So yeah, it would have been worse if I did more binary ops, right? signed integer, delete that line, do a import, copy, go to multiply, paste that there and that there, signed, delete that line, copy, import, save, equal to, paste, import, paste, signed, import, delete, copy. Okay, yeah, here's where we're starting to get problems with the decimal one. The cat has brought me a toy. He brought me a toy. You want me to play get the mouse or get the fish? She wants me to play get the fish. Come here. I'm streaming though. I can't play this game. Playtime. She's like, playtime will be now. Here, I'll just throw it. There she goes. She stopped. She's like, why is it over there now? So this should be cast to decimal. We'll have to fix that, right? So the type is going to be wrong. It's going to be an option. Yeah. So this should be F64. Delete that. Yeah. So that reduces to that. And then this reduces to that. And this to that. Get rid of the map. We need the parse. I guess it's float error. Guessing. Get rid of that. Okay, down to 3 errors. Cast to string, right? Then follow the, right, so this should just be string, right? And then all of these like values just disappear. Well, not all of them. All of these. All of these. Well, not all of them. Hold on. What do you want, kitty? You want more food? Okay. Wants more of this. So she gets what she wants. She wants it. He wants it. There you go. Go ahead. She hungers. All right. Yeah, I think we do delete all that, right? And delete the... Yep. All right. 3 errors left. Cast to string is infallible. Do I even need cast to string? I think I do because really it's sort of an unwrap to string. There's a clone in there. It's, yeah, it's different enough, right? Okay, then one more, cast to Boolean. This is fallible, I think. Is it cast to bool? Or did I just say use try? No, there's a cast to bool. Import, there we go. And then, yeah, this is result bool. So then I don't need to map this. And this is just okay, false. Go back. modulo. Can I just copy from like multiply or something? Yeah, that line to there. Delete that, copy that to there. Signed integer. Okay, it says I have no warnings, no errors, but isn't that a problem? Oh, wait. No, it's going to say it didn't work. It's going to be reachable and it's going to say, yeah, this should actually crash when I run the tests, right? Yep. So we're going to get entered unreachable code, which makes sense to me. So, yes, so we actually have to do a cast to, let's just fix it. Cast to decimal here. And this has to be a cast to string, which is infallible, right? Cast to string is infallible. Oh, am I gonna have to do all that for all of them? Do I have the same? Yep, I do. I should have just done it when I saw it. I guess it's not too bad. That one's undefined anyway, right? I have to go through all of these and just make sure yeah, that already does it. This one needs it. Actually, I know what to search for now. I just searched for unreachable, right? Let's search for unreachable. Yeah, this cast didn't work, which got copy pasted everywhere. So there's only 2 more places. How come I can't click there? There we go. Yep, so copy and paste and rename that to decimal and import it. One more here. Should have just copy pasted from the last one I did. Okay, now we pass all our tests, right? Yes. Oh my god, that was a lot of work. Should I test that I actually get good diagnostics now? So like I had some negative tests in here. Oh, hey, you got past my bad cat detector. Get out of here. Hold on. Let me get the cat. You're being a bad cat. She got past my being a bad cat filter. She's messing around with my cords. She like thinks that the cord that goes into the wall is some kind of spider. Tests and ops. Right, I need to look for the negative tests. So the ones that assert foo.error. 3 of them. Okay. I want to run it and see the diagnostic. Cannot add something to a nil value. And it gave us the line numbers. Okay. Next one. Overflow subtracting unsigned integers. Cool. Subtracting strings is undefined. Correct. Okay, good. And then Oh, a couple other diagnostic places that did conversions was bounds, right? Bounds. Just one bound, several bounds. Oh, I don't have an invalid bounds. Should I add one? Oh, this is a bound statement. There it's part, I guess, right? Where I tested like illegal part bounds. Bad format, argument, ignore, look ahead. I guess not. Now I don't remember where I tested it. But there should be a test for like the bound being bad. I just don't remember where it was. Was it simple format? I don't remember. It wouldn't have been any of those. Integer? What do we get if it's 0? Actually, I'm curious what if we do set up logger here, what do we see in the diagnostic? We see exceeded boundary. Yeah, but it didn't actually say where. Okay, that's a problem. That diagnostic should say it's on this line, so I need to track that down. Exceeded boundary. Yeah, these errors, that's bad. So that's because it's in a component, not in the context, right? And it doesn't have a context. Okay, so yeah, all of these ingest as are not printing context. But we have it here. I remember looking at this before and thinking that it didn't quite look right. So here we can do an on error. If the format is needed, it'll print it, but these internally do errors, which is bad. What about this one? Oh, these are returning a return scope. So they're supposed to handle it. This will handle it correctly. So it's just these then. Actually, then I'm going to search for all errors. Wait, so collisions on names in are going to also print a bad diagnostic? Hold on, let me see that. That would have been like a references test, right? 2 levels, unfound name. No, it gives me a span. That's the unfound. No, but specifically a collision. So that'd be like if we had 2 parts with the same name. Do I have a test for that? Bad argument, bad form. Oh, here we go. Bad format. We get a good diagnostic for that. Okay. Argument, ignore. Maybe that's the problem. I never made a test for it. So that's why it's bad. Shocked and Max Shock. Hey there, Robotic Head. Actually, you've been here a while. I just didn't say hi. Sorry about that. So, where would I check this stuff? That should be a problem. Wait. How do we add -1 How come we didn't get a diagnostic for that? Oh, because that isn't an error. We can add -1 to lulls. It concatenates. Okay, never mind. Wait, why didn't I get an error for this one? D to I. It just says it passed. We didn't get an error printed. Accumulate doesn't print an error. Okay, that's a bug. How am I letting these bugs get in? Context. Statement. Accumulate. Can't read it. It's not wide enough. Accumulate. I think I see why. This returns a result, and it doesn't do a diagnostic here. I guess it was assuming that this would do it. And okay, it does if it's not local, it does if it's not found. Where's the other error then? Wait. So that one does it. Is it the add that didn't do it? Yeah. We're ignoring the error. What the heck am I doing here? I'm ignoring the error. We get a string back. We're supposed to say something here. What do I do in the binary operator add? Binary operator does a diagnostic with the message. So we need to do that too. Here. We need to do that. Message. Yep, I just forgot to do it. So, where was that now? I don't remember where it was. Integer. I don't remember where it was. Accumulate or something? Accumulate. That's right. Yeah, this one. There it goes. Cannot cast decimal to sign integer. Converting from decimal to integer is ambiguous. And it flags this one. Okay. That's scary that like I let the diagnostic not get printed. Because I'm thinking ahead to where we're more moved on to more complicated things, and I make an error in a format, and we see the error flag go up, but we never see a diagnostic for it. I'm gonna be like so pissed. It's been lurking, also having meetings. What are you having meetings in the middle of the night for? Oh wait, you're probably in a different time zone. Okay, so assignment is accumulates okay. What about assignment? Do I have any errors here that I want to see the local declared? Shouldn't I have like, there should be an error if you try to assign to a part. So like bar equals 5 should fail, right? Assignment to part should fail, right? Assert an error. We should have no value, so this should be none. Bar is something, we don't care about that. Okay. This should just fail, but bar should still have a value. In fact, I should probably assert bar's value. Yeah, just copy this. Bar's value will be 42. So that's food dot key children dot get bar unwrap value. All right, let's see the diagnostic, make sure it's correct. It failed. Why did it fail? Bar is not local. That's the correct diagnostic. Bar is not local. But it panicked on, oh, we asserted that there was no error. No, there's an error. Actually, not only that, but we should do like let bar equal and then just do the get unwrap. Let that panic because I want to just say bar's value should be 42 and also bar's error should be true. No, bar's error should be false. So not. There's nothing wrong with bar. Component, why is that a problem? Missing tokens. What token's missing? Oh, that should just be assert. Okay, yeah. So do something like this and bar doesn't get an error, but food does. Bar should have its value. Food does not have a value. Okay. Yep. Pass the test and we get the correct diagnostic. All right. Hey there, standard robot. I am a standard Raimu. I'm just fixing some problems with my parser. My parser, if you, any of my tests is kind of a good quick overview, right? I'm making a tool that can take some kind of generic program that can parse data and interpret it. So this is in these tests, they're very simple. So we're just passing it a single byte and we're saying, use this recipe on the byte. So the recipe says that foo, it consists of a part called bar that's 8 bits long, and you should interpret it, those 8 bits as an unsigned integer. And then we're testing what happens if you then try to change the value of a part. We do that, and that should generate an error. And so we never get to the return bar statement. So foo doesn't have a value and it has the error flag set. But we did successfully parse a bar, so we should be able to get it. It's not an error and it has the value 42 because that's how we told it to interpret the data. We're getting the correct diagnostic. It tells us where in our program it was, which is that line. No, this line. And it says bar is not local, so we can't assign to it because it's not local. And to give you an idea of like a more general thing we might do with this, so we might program the tool to understand different kinds of images, right? And one kind of image would be if it starts with GIF, interpreted as a GIF or GIF. And that's the structure of one of those. It has a header and a trailer, and the header has a signature and a version. So the programs my tool compiles and runs are really just format recipes, and they're matched up against an input file or bitstream, kind of like how Wireshark works. Put in a bunch of bytes from a network interface and it figures out where the packet boundaries are and what's in the packets. Yeah, so that's what I'm working on. And a little more background. I've said this like a dozen times, but people are coming and going, so not everyone's seen this. So I call it DataDisintegrator because I can't think of a better name, but its job is to do what I describe. It's a domain-specific language describing a data format. I used the word disintegrate because it's splitting apart all the bits of the file so that they're separate now, and we assign a meaning to every single piece, every bit. Every bit will fall into a part of something, and its meaning will be interpreted. So I originally wrote it years ago in C++, and I'm converting it to Rust because it's fun. Also, the C++ never got past this stage, and then after this, I wanted to make a user interface, I wanted to script it, a bunch of other fun stuff. So I'm mostly just implementing the things that are missing, so I'm following the to-dos. That's why it's to-do-driven development. So I'm implementing binary operators today, and I have some of them, but not all of them. So I did all the ones that aren't to do here. And then I got sidetracked because I wanted to handle errors correctly. So now I think we're handling errors correctly, where we are casting specifically the right-hand side, and we're using the question mark operator because these casts return like a lot of information about what we're trying to cast from and to, and the reason if it didn't work. And it's convertible through a question mark operator to string because this type we implement from that to string, and we just use format. So it took me a while to figure out that that's what I wanted to do. I also got sidetracked because I added a Boolean type. Oh, I didn't go back and add literal Booleans though. Do I want to do that? Maybe tomorrow. Let me leave myself a to-do in case I forget. Oh, I could actually put it in line here. To do. Add literal Booleans. So we don't have literal Booleans yet. Hey there, the Wrapped. Spooky Halloween noises. Yeah, resurrecting him. You're welcome for the quick run through. I'm getting better and better at it, I think, unless I'm getting tired, which is probably true right now because it's 11 p.m. for me and I have to get up at 6 a.m. to do this again and then go back to work. Yeah. So I don't know. I'm having fun, so I kind of don't want to stop. Do I want to do another one of these? Please, sir. I want more. So we did equal, right? What if we just do not equal? Because equal and not equal are pretty close. So let's copy paste, call that not equal, and then in value at the top, we'll do a mod not equal. Actually, before I get too far, I want to write the unit test for it. So that's in ops. At the end, probably we have the equal test. Yeah, there's the equal test. So the not equal test, we're just going to change the program to say not equal. If you're wondering why it does that, it's because I'm using a font that has clever, what is it called? I have a font command that explains this. Ligatures, right? Vera code has nice programming ligatures. So it's really exclamation mark equals, but it shows up as a not mathematical not equals. So if 42 not equals 8 will be true, and 50 not equal 50 will be false, right? So run that test, and it won't compile because I messed it up. The not equal we just have to say that's not equal, right? Okay, so back we go to the test. Hopefully I hit not implemented. Yeah. Because I have to actually plug it in there. That's what's todo-driven development, right? So this should be real easy. Left-hand side not equal to borrow right-hand side. If you're wondering why I'm not using like the built-in Rust like that, and maybe I might have to dereference that, that's because that is the partial equal. It's not going to show it here, but like, yeah, you have to implement partial equal. But the problem with that is those don't support returning a result of any kind. You just get with partial equal, you just get a comparison result, and that's just like less than, greater than, or equal to, or something like that. But in this case, we actually can generate errors because we're doing implicit typecasting, which can fail. And that's why these question marks are here. We might fail because you give it a decimal, like a 3.14, and it's like, I don't know how to convert that to an unsigned integer because it's ambiguous. Did you mean to round it? Floor, truncate, ceiling? What did you want, right? And we want to see that printed out as an error message if I were to accidentally do that. So actually an example of that would be if I said like not equal to 3.14. Now we'll get a nice diagnostic saying that's ambiguous. Cannot cast decimal to unsigned integer. Converting from decimal to integer is ambiguous, and it tells us that it's on line 5, columns 13 to 30, which is right here. So even comparison is fallible in my language. So yeah, I can't use some of the built-in Rust traits for like partial equal, for example. So I just added methods to my value type. And again, this value type is just all the different kinds of types that my parser will support, the fundamental types. Anything larger than that is called a part or a composite, a data composite. I don't know if I have the theme thing, but what was there? There was a way to see what theme we're using, right? Is it like appearance? It was one of these, right? Anybody remember how to see what theme I'm using? I forget which menu shows me what theme I'm in. Preferences? Theme. Actually doesn't say, does it? Theme? There we go. I'm using modern, dark modern. Dark modern. Did we pass this test and I just wasn't, I'm just not remembering it? No, we're not passing it. Yeah, because I just copied equal to not equal, right? So not equal. I think all these equals just become not equals, right? And then we're done. Done. First try, right? First try. Even if it's not the first try, say first try. It'll make you smile. Okay, I'm getting tired and it's past 11. We got plenty to do tomorrow. One of them was that Booleans, we need to have literal Booleans, right? And value. I think that's what I'm gonna do tomorrow morning because that's a little fun thing where I can auto update the lexer and the parser and the compiler, and should be pretty simple but useful because then we'll be able to like have like a while true instead of a while one. Wouldn't it be nice to say that? Right now, my GIF, I have to say while one, but it'd be nice just to say while true. True. You know what? Another useful syntax might just be loop. What if I add that too? Then I wouldn't even need a true anymore. That's a good thing to add to this global to-do list, right? Do I already have something that says loop? I have that. Yeah, but I don't have one for add or just consider adding. Consider adding syntax for loop, as in Rust, an infinite loop, unless break or return is encountered. So that would be a degenerate form of while, which has no condition, or the condition's always true, right? So I might do that tomorrow. I might add the loop, and along with the literal Booleans, because then we get to like touch up the lexer and the parser. So yeah, I usually stream 7 a.m. Pacific time. I'm streaming in the evenings now when I have the opportunity because I'm actually having a lot more fun doing this than I am at like what I used to do, which is just play games. So I hope you'll come back tomorrow morning if you're around. Otherwise, no big deal. I think we are gonna raid someone completely different. We're gonna raid a pixel artist. In Australia, no less. So yeah, thanks for being here. Hope you had fun. I will see you next time. Bye-bye.